Hello, my friends, and welcome to FISHTORY. I'm Alexander Williamson, your host today. These are plants that can live without substrate in the aquarium. So, how do they do it, and what exactly are we going to be talking about? Well, there are 4 categories of plants we're going to cover in this video, and we're going to talk a lot about the quirks, the pros, the cons, and the propagation of these plants and how best to take care of them. So let's take a look in the aquarium and start looking at some pretty plants. All right, my friends, we need to talk about the 4 kinds of plants briefly before we get into the science on this video. And first, we're going to start with floating plants. They're the most familiar to most people if you're thinking of plants that don't need any substrate. And they usually grow up and out of the water, which allows them to essentially grow with a little cheat or hack, which allows them to access both light and CO2 as well as transfer oxygen without water in the way. Now, these plants usually grow in pretty low nutrient water, but they still have a really high surface area of roots to pull off the nutrient feeding that they do from the water column. Whereas plants with stems and roots that are down into the substrate, they don't have any of those straggly, loose stems that are white roots. But when our second type of plant breaks free from its rooted grip, it turns into floating plants that can live long-term at the surface of your water, and these are usually stem plants. So these stem plants, what they do is they use a trick and they put out all these extra little nodes. And one type of stem is for holding on to things and trying to grab something. So if the plant breaks and floats downriver, it can hope to snag onto something and then grow in that spot and then send roots down towards the substrate eventually. But long term, you can just trim these off over time, and as long as it has enough of the feeder stems, which have forks in them, so if they have texture like this with little forks and hairs on them, they're maximizing surface area and they're feeding from the water column. If they're straight and rather tough, they're trying to hold on to or wrap around something. And that's from your stem plants. Now, the third type of plant we're going to talk about is your vining or chaining plants, things like Valsenaria, where oftentimes these plants are in soil or a substrate, but it's very poor quality. And so they've designed the ability to take a pile of nutrients, whether that's something that's dying in the sand or gravel that normally a plant couldn't even grow in, and growing from there and then growing along in the water until you have a whole long chain of the plant. But yet again, when nutrients is low in the water, you get a lot of these scraggly stems that are trying to both find something to hold on to and that are trying to eat nutrients out of the water column. So it's important to either dose nutrients into the water column and you'll get less of these straggly little stems, or to have flowing water with trace nutrients that is able to pass over all that surface area multiple times an hour and feed the plants. So think like a plant when you're trying to figure out what they need. When plants break free like these last 2 types, they also tend to have their leaves oriented upright, and they also tend to want to grow up and out of the water, so they can use that trick that floating plants do so that they can use the oxygen, the sunlight, and the CO2. Now, our last type of plant is going to be our typical plants like Anubias, Bulbitis hedulata, and Bucephalandra that anchor themselves to things, but they also directly feed from the water. So they've evolved a different root system called rhizomes, and we'll explore all of this right now. All right, so regardless of what kind of plant you have, it usually will have roots. And the roots have evolved into 2 major classes. You can see here, this is a stem plant that usually has its stems in the ground. Pardon the cat. She wants to be in the video. You're in the video now, Sumi. Yay! Okay, so these plants want to be in the ground, and they get 90% of their nutrients from their roots. So therefore, when they break free, even though they may have evolved to survive breaking free, they still put out a root to try to hold on to something, and they still put out roots with extra little roots forking off of them, and these are looking for nutrients. So you usually have two types of roots. You have an anchoring root or a grasping root trying to grab onto something as it floats downriver after it broke off from its main plant. And then you have one that's trying to get as much nutrients out of the water column as possible. Now, the other kind is a true floating plant that was evolved to not be anchored to anything, like this Riccia fluitans, or rather your red root floater. And if they have different nutrient levels, different light levels, and different flow levels, these plants can look very different. So here we have one that was under highlight right under this light here, and you can see that it's getting a lot of its energy right from the light. The other trick that these plants have is that they are able to float, and so half of the plant is above water at all times. This means that they basically get pressurized CO2 24/7. So just like a fancy aquarium where you have an aquascape that may have CO2 to make all the colorful plants, this is just as high tech through natural evolution because our atmosphere has CO2 and carbon in it as well. Now, this also allows it access to the light much easier because every 6 inches down in the water column, there's less light. So if you're keeping these floating plants, they're great. You can have all sorts of these floating plants, from red root floaters to duckweed to wolfia with this little furry purple guy here to the salvinia or the cat's tongue. And if we come over here where my cat is, we can actually check out a whole bunch of salvinia. And these floating plants, this category, one of the 4 true floaters, they want still water, but they will usually over time start building up so densely that they start to stack on top of each other. So they're not always the best plant for every aquarium because they do require quite a bit of maintenance. Also, they can choke out the entire surface of an aquarium, and they can cause you to lose your oxygen exchange from the water and the CO2 exchange from the plants. So it can actually cause your fish to lose air, and they can suffocate if you have too thick of duckweed or salvinia on your aquarium top. So beyond this, we have plants like Anubias. Now these plants are designed to be anchored, and they're designed to not have roots that are actually eating any sort of nutrients out of soil or substrate. Now, sometimes you'll see a plant and it will have something like this little Anubias here, and it will be anchored to a piece of wood, and you'll see that the roots are really just to hold on, while there's other roots that then are wider, and they are just out in the water, and they work in tandem sometimes with protein layers, algae, and the flow in a tank to get nutrients to their roots. So if you're growing any plants like Anubias or Bulbitis hedulata, this awesome African water fern, or any of the old school Anubias or Bucephalandra, Java fern, any of that stuff, all that needs is flow and access to light and something to anchor itself to. The rest is really low energy from the water. They're designed just like floating plants to need very little from their roots. Now, the other 2 big categories we're going to talk about in this video are your vining plants, such as your moneyworts and pennyworts, or your hydrocotyle plants, which they start all the way here and they go all the way around to here, and they grow just in these thick vine systems, and they put out all sorts of graspers, and they put out all sorts of stems for nutrients. And you can see, even though they're kind of mushy and dark looking, they're constantly sucking up nutrients wherever they can get it. And another good example of this is this Cardamine lyrata. This is another one. It looks absolutely awesome. It grows like a chaining plant, and then it basically grabs onto anything it can with these long, thicker roots, like right here that I'm holding, whereas these whiskery roots that split and have a bunch of different forks in them, yet again, those are sucking up nutrients from the water. Now, these usually have a anchor point or have a spot where they want to put the roots into nutrients, and then they can send that nutrients all up and down the plant for literally meters or yards down the plant and share that nutrients while they get their carbon or oxygen, CO2, and sunlight locally in the plant. But their nutrients, they usually share down the network. However, these plants evolved to also reproduce by breaking off from the mother plant and floating downstream or floating across a lake and holding on to something, having their roots snag something, and then basically their roots will work their way down towards the bottom or towards nutrients. And this is where I think you'll have the most success beyond just floating plants, is quick growing plants like stem plants that actually are growing immersed. So these plants, they break free, and even though they evolved to grow from a aqua soil or from a substrate, some sort of dirt or some sort of sand or clay or mud, they then work their way up towards the top of the water, and when they get to a certain size, they get brittle and they break, and either fish or creatures in the water will break them off, or time and waves and storms and things break them off. And you can actually see here, this is a good example of one. This is not actually in the ground. This is a Ludwigia arcuata that is actually putting out roots to try to hold on to something, and it managed to hold on to a bunch of other plants here. So we have examples of other plants like this, like Potamogeton gayi, or like Ludwigia red star, Ludwigia super red over here, Ludwigia rubens, or things like Rotala purple Vietnam. Now these plants tend to be much more colorful. So also, like down here, this Kabamba furcata, it is designed to grow out of the ground, but when it breaks apart, you can see how thick and bushy and colorful it is when it's in the ground, but when it breaks off, it becomes spindly like this, and the leaves get thinner and farther apart because there's less nutrients. So let's look at this great example here of Bacopa monieri crossed with Bacopa salzmani, and you can see underwater, it's a cool plant. It gets a little bit of a purple hue, and it grows like kind of a waxy look. And the nodes, they alternate so that they go left to right, and then north to south, left to right, then north to south, and they're evenly spaced in water where they have access to roots that can get good nutrients. Well, when they break free, they then put out these nodes, and anywhere there is a set of leaves, the nodes will start to put out roots. And there, yet again, are two types. There's the kind with the forks and the little finer roots, and those are trying to maximize surface area so that while they float, they can get the most water and nutrients from the water into the root system and use that while they're floating downriver. Then the longer, harder, and stiffer roots will grab onto something and start to wrap around it, and it will then send its roots down to try and find nutrients. But it also has that wonderful trick that floating plants do of basically it can float downriver as a chunk that broke off and be totally viable. So I can literally break this plant yet again at almost every node where there's a root coming down, and it will grow as its own plant, just like this first chunk will too. And even though the roots came downward from this plant originally, it oriented itself floating so that the sunlight was on the top, and these leaves got very thin and very pink, and they lost a lot of their green that you would associate with photosynthesis. Well, over time, they didn't have enough nutrients to be doing that. So when they got out of the water and the plant started to grow like this, just like these others are, which are the same plant, you can see that the color went from pink and it actually turned back to kind of a green color. which means that it was getting more of the nutrients it needed, and it was able to do more photosynthesis. In the aquarium, sometimes we want plants that have bright colors. We want something like this Ludwigia red star with this cool pattern. And the way we get that is we have very low nitrates, nitrites, and no ammonia in our aquarium. Or in other cases, we up the level of certain nutrients. And it's just different for every plant you get into. So you'll have to do your research and find out which plants get brighter with different nutrients and which ones actually get greener and bushier with nutrients. Most actually get brighter when they are starved of nitrates and nitrites. It is an urban myth or a wives' tale that these plants require iron to be pink. I have a whole video on the details of this, but in reality, they just need their basic nutrition met, and actually, they want low iron and very low nitrates and nitrites in order to turn those beautiful red colors, with the exception of Alternanthera renickii and or scarlet temple plant. Now, as we said, the floating plants have evolved to actually survive outside of the water, so they can live in much darker places and utilize much more light, as well as utilize that CO2. But when plants are in something like sand that doesn't have much nutrients until fish and plants exist for years on end, placing debris in the water that then becomes mulm, which then becomes fertilizer, it's hard to gather that nutrient. So I just wanted to show you one more little cool trick that those vining or chain plants can do. So here is Valsenaria. This is tiger val. And if we look carefully, you can see that plants actually create their own little traps for debris. So look at all this fish poo and or extra food and waste and algae. All this is trapped by those roots that this system has. And when they get all this nutrients trapped here, they are then able to work with bacteria and fungi and convert that into fertilizer, and that allows them to then grow up and around and even grow so wild that then they'll break off, and pieces like this will float around and try to go find a home somewhere else in the world. And they use that saved up energy in the form of starches in their root and in their thicker parts of their stem, starches and then later sugars, and they use that as saved up energy, and they float on and go find a home elsewhere, which is pretty darn cool. Alright guys, I'm gonna leave you on the note of thanking you so much for being here, being a part of the channel, and for watching my videos and learning alongside with me. And I hope you guys have a wonderful day. Bye.